today we have this problem before us, and from the question we were asked to find the current 1 and current 2. That's what the question asks us to find. When you are given a problem like this, you settle down, understudy the circuit diagram, right? This is the cell or battery of cells. It is 5 volts, and then the internal resistance of the cell is 1 ohm. Then the current is leaving the cell and going into other parts of the circuit. At point A, point A is a junction, and then we have current 1 passing through the 12 ohms resistor. Then the current 2 is passing through the 2 ohms resistor and 4 ohms resistors respectively. So what are we going to do? I told us last time that when we have a current entering a junction and we have other currents leaving the junction, what it means is that the current leaving the junction is equal to the sum of the other currents. The current entering the junction is equal to the sum of the other current leaving the junction. So it will be correct to say that the current I is equal to I1 plus I2, because the current I is entering this junction and the current I1 is leaving, the current I2 is leaving the junction. So this could be called our first equation. Then at point A, all right, voltage across the 12 ohms resistor is equal to the voltage across the 2 ohm resistor plus the 4 ohm resistor respectively. So we can, in terms of their voltages, we said this one is equal to this. So if using Ohm's law, all right, we know that for every V there is current times resistance. Okay, so what we are going to do is, for this we have current 1, all right, multiplied by resistor, the 12 ohm resistor, equals current 2 multiplied by the 2 ohm resistor plus current 2 multiplied by multiplying by the 4 ohm resistors respectively. So if we substitute the values, what we're going to have is 12I1 is equal to 2I2 plus 4I2. Call this one equation 2, because the two equations will be very relevant to the determination of the 3 currents. All right, so the next thing we are going to do is to write equation of electromotive force. That electromotive force is equal to the current passing through the circuit multiplying the total current plus the internal resistance, this total resistance plus the internal resistance of the cell. This one now becomes our equation 3. With this equation 3, we can be sure that our values will be determined. So the first thing we are going to do is we try to eliminate one of the currents. We start from equation 1, all right? From equation 1, our current 1 is equal to current, take away current 2. So we substitute this into equation 2, put into equation 2, simply done this way. All right, why are we trying to do this? We have 3 equations here and we are looking for either current, we are looking for current 1 and looking for current 2. So if we substitute this into the second equation, what we are going to have is 12, all right, into I minus I2. The result is equal to 1 ohms, all right, 2 times current 2, and then 4 times current 2. So if we open the bracket, we are going to have 12I minus 12I2 is equal to the current 2 times the current I2 plus 4 times the current I2. All right, all the terms with I2, we try to balance, to bring them together. So what we are going to have is our current 12 times current is equal to, we take this one to the other side, we are going to have current times current 2 plus current 2 times current 2 plus 4 times current 2. And that's going to give us 12 is equal to, if you add all of these together, that's going to give us 18 times I2. All right, so we take note of this as equation 4. Now, at the different levels of the equations, it's actually, we are numbering the equations because we want to make it a little bit more simplified for us. At every point we want to make reference, all these equations we have numbered will help us meet our goals faster than it should. So let's use equation 3. Equation 3, electromotive force is 5. So our 5 is equal to, we have current. And then the total resistance, we need to know the total resistance. That's total resistance plus 1, because our internal resistance was given as 1 ohms. So let us find the total resistance. Okay, so for R of 2 and R of 4 in series, if you combine them, the R between 2 and 4 is equal to, you have 2 plus 4. The reason is because when resistors are in series, to be able to get the effective resistance, you have to add them. So if we add, that's going to give us 6 ohms. The next thing we are going to do is, if you combine this and this, they are now together. So the result of that is now in parallelity with the 12 ohms. So the result of that is equal to, you have 1 over 12 plus 1 over 6. So if you find the LCM, you're going to have 3 over 12, and the result is 1 over 4. Therefore, the R between them is equal to 4 ohms. All right, is equal to 4 ohms. Now, the result of this, and that, all right, is going to be in series with the 1 ohm. All right, so the total resistor, pause. Therefore, the total resistance in the circuit is equal to 1 plus 4. That's going to give us 5 ohms. Hence, the equation 5 equals I into R total plus 1 now becomes, we have 5 into I, then we have 5 plus 1. So our I is equal to 5 over 6. So this is the value of I. All right. So we substitute this. Since we have gotten the value of I, of course, I is expressed in amperes. Now, in order to be able to find the other currents, namely I1 and I2, we make reference to the existing equations. For instance, equation 4, all right? So put the value of I into equation 4. So equation 4 says that we have 12. That's going to be 12, then 5 over 6. All right. Say this is equal to 18I2. All right. So we can simplify this first. Have 12 times 5 over 6 is equal to 18I2. So 6 here is 1, 6 here is 2. If you multiply this, you're going to have 10 is equal to 18I2. It simply means that our I2 is equal to 10 over 18. Hence, I2 is equal to 5 over 9 amperes. That's the value of that. Finally, since I is equal to I1 plus I2, if we substitute all the values, we have 5 over 6 is equal to I1 plus 5 over 9. So our I1, therefore, our I1 is equal to 5 over 6 minus 5 over 9. Because if you find the LCM of this, that's going to be 18. So we have 15. 6 into 18 is 3 times 5, that's 15. Then 9 into 18 is 2 times this, that's going to be 10. And if you solve this, you're going to have 5 over 18. So our I1 is equal to 5 over 18. All right. Of course, 5 over 18 amperes respectively. So these are the values for currents I1 and I2 respectively. Hope you learned something.